The quantum theory is only controversial when you talk to philosophers, theologians, and the average person. To a physicist, it's accurate to 1 part in 10 billion. We can take an atom, shine a laser beam at it, and I can predict the properties to 1 part in 10 billion. The consequences are the internet, GPS, laser beams, computers, fiber optics, a broadband internet. All of that is a consequence of the quantum theory. Now, you'd think that a theory that powerful would be logical, compelling, and intuitive. Wrong. It is the most bizarre theory ever proposed in the history of science. Einstein couldn't get his head around it. It reduces everything to probability so that there's a probability that electrons can vanish, reappear someplace else. Electrons can be 2 places at the same time and exist in multiple states at the same time. Now, that's stupid. I mean, how can you possibly exist 2 places at the same time? How can you be in multiple states simultaneously? Well, get used to it. That's just the way the atomic world is. So why don't I vanish and reappear someplace else, like on Mars or the moon? There is a probability that I'll do that. In fact, we give our PhD students at our college a question. Calculate the probability that you will vanish and wind up on the planet Mars. Give me a number. It turns out you have to wait longer than the lifetime of the universe for that to happen. But it's a calculable number. This is insane. This is absolutely counterintuitive. But the problem is, it's right. That's how our world is constructed. Our world is stranger than you realize at the atomic level. Now, we don't see it because we average out all these bizarre quantum effects for large objects. We consist of a lot of atoms. But at the atomic level, electrons exist in multiple states all the time. And you know what that's called? That's called the laser beam.
Einstein was asked the big question, is there a God? Is there a meaning to everything, right?
Right.
And here's how Einstein answered the question. He said, there really are 2 kinds of gods. We have to be very scientific. We have to define what you mean by God. If God is the God of intervention, the personal God, the God of prayer, the God that parts the waters, then he had a hard time believing in that. Would God listen to all our prayers for a bicycle for Christmas and smite the Philistines for me, please?
Right.
He didn't think so. However, he believed in the God of order, harmony, beauty, simplicity, and elegance, the God of Spinoza. That's the God that he believed in because he thought the universe was so gorgeous. It didn't have to be that way. It could have been chaotic. It could have been ugly, messy. But here we have the fact that all the equations of physics can be placed on a simple sheet of paper.
Right.
Einstein's equation is only 1 inch long. And the quantum theory is about 1 yard long, but you can squeeze it onto a sheet of paper.
Right, with a small enough font. No.
Right. And with string theory, you could even put those 2 equations together. And string theory can be squeezed into an equation 1 inch long. And that equation, by the way, is my equation. That's string field theory. That's my contribution.
Right.
But we want to know, well, where did that equation come from? You know, this is what Einstein asked. Did God have a choice? Was there any choice in building a universe? When he woke up in the morning, he would say, I'm going to create a universe. I'm going to be God today. What kind of universe would I create? This is how he created much of his theories.
In parallel worlds, you discuss time travel. Is it possible?
It could very well be possible. Stephen Hawking has said that, yes, time travel is possible, but not practical. In other words, don't expect an inventor to create a time machine in their basement today. We're talking about the energy of a star, the energy of a black hole. But in principle, if you could master that energy, then you might be able to bend time into a pretzel. The mathematics says so. Even Albert Einstein realized in 1949, his own equations allow you to go backwards in time. If the universe rotated, for example, a very simple kind of universe, a rotating universe, and you go with the flow, you go around the universe as it rotates, you can come back into the past. So simply walking around a circle, you come back not where you left, but you come back yesterday. So even Einstein realized, oh my God, his own equations allow for time travel. So in his memoirs, of course, Einstein had to address the question, is time travel possible? And